Hi, Assalamualaikum. Our group will be present about one of application of differentiation, which is related rates. Let me introduce you our team. We have Nick Muhammad Adam Daniel bin Asmadi, NORSYAFIKA Alia binti ZULKIFLI, SHAHEERAH AINA binti AZMAN, and we are from FOAS 1202_4, and we are from group 9. In mathematics, differentiation is the process of determining derivative or rate of change of a function, in contrast to the abstract character of the theory that underpins it. The practical technique of differentiation can be carried out using solely algebraic manipulation, employing three basic derivatives, four rules of operation, and knowledge of how to manipulate functions. They are techniques to solve differentiation problem that we can apply, which is derivative of sum and difference, derivative of a product, which is the product rule, derivative of rational function, which is quotient rule. The rate of function is defined as dy over dx, or fx, or y. There are five applications of differentiation, which is related rates, analysis of function, decrease, decrease, and concavity, maximum and minimum problems, analysis of function, relative extrema, first and second derivative test, Rolle's theorem, and mean value theorem.
Okay, let's begin with A. Surface area changing. Consider the given closed rectangular box with dimension x, y, and z, and assume that x, y, and z are functions of time. The surface area of the box, which at the areas of 6 rectangular surfaces, is equal to S equal to xy plus 2xx plus 2yz. Given dx over dt equal to 4 feet per hour, dy over dt equal to negative 6 per hour, and dz over dt equal to 3 feet per hour. So find ds over dt when x equal to 5 feet, y equal to 4 feet, and z equal to 6 feet. Now differentiate the surface area equation with respect to time using the product rule, getting ds over dt 2 in bracket x dy over dt plus dx over dy close bracket plus 2 open bracket x dz over dt plus dx over dtz close bracket plus 2 in bracket y dz over dt plus dy over dtz close bracket. Now let dx over dt equal to 4, dy over dt equal to negative 6, dz over dt equal to 3, x equal to 5, y equal to 4, and z equal to 6. Let's substitute all the value in question and we will get ds dt equal to 2 feet square per minute.
Now, let's proceed with question B, which is volume changing. The volume of the box is V equals to length times width times height, which is also equals to x times y and z. We are given that dx over dt is equal to 4 feet per hour, dy over dt is equal to negative 6 feet per hour, and dz over dt is equal to 3 feet per hour. Let us find what dv over dt when x is equal to 5 feet, y is equal to 4 feet, and z is equal to 6 feet. Now, differentiate the volume equation with respect to time t using the triple product rule. We are getting that dv over dt is equal to dx over dtyz plus x dy over dtz plus xy dz over dt. Now, let dx over dt equals to 4, dy over dt equals to negative 6, dz over dt equals to 3, and x equals to 5, y equal to 4, and also z equals to 6. Now, we have to substitute all the value that we have into the equation and solve it. And finally, we'll be getting that dv over dt equals to negative 24 feet cubed per hour. That's all for question B.
C. Main diagonal changing. Consider the given closed rectangular box with dimension x feet by y feet by z feet and the main diagonal of length feet in the given diagram. Consider the two right triangles of h lengths x, y, and w z and l respectively. Apply the Pythagorean theorem to each right triangle, getting x squared plus y squared equal to w squared and w squared plus z squared equal to l squared. Substituting for w squared leads to the following main diagonal equation, which is d in bracket l squared equal to d in bracket x2 plus y2 plus z2 close bracket. 2l dl over dt equal to 2x dx over dt and 2y dy over dt plus 2z dz over dt. L dl over dt equal to x dx plus x dx over dt plus y dy over dt plus z dz over dt. Now, let dx dt equal to 4, dy dt equal to -6, dz dt equal to 3, x equal to 5, y equal to 4, and z equal to 6. The equation L square equal to x square plus y square plus z square becomes L square equal to 52 plus 42 and 62. So the L square equal to 77 and L sits 77. Let's substitute all the values in the equation and solve correctly so that we get 1.595 feet per hour.
In conclusion, we can use the application of related rates to find the rate change of y with respect to time, a spatial ratio in which the two terms are in different units. Solve for the unknown rates.